Hi, I'm Irene.
Hi, and I'm Danny, and welcome to episode 3 of openEuler Tech Day.
In our previous 2 episodes, we introduced the basic concepts of openEuler and looked at its history and development.
We also interviewed Dr. Xiong Wei, one of the founders of the openEuler community, who held an online Q&A session.
We received many questions about the recent innovative version, openEuler 22.09. So today, we will explain the key features of openEuler 22.09 in detail. Before we start, I have a small question for you. Do you know the meaning of the numbers in each openEuler release?
You know what? I have never even considered that before. I just assume that a new version is based off the previous one.
Not quite. It's actually quite intuitive. The number 22.09 indicates that the version was released in September, the 9th month in year 2022.
I see. Since innovation versions are released every 6 months, we can predict that the next version will be openEuler 2303.
Exactly. Now let's get into today's topic, the key features of openEuler 22.09.
The latest version aims to release full computing power from diversified hardware architectures and interconnect openEuler with OpenHarmony. With the X2 openEuler migration tool, you can easily migrate your environment from one OS to openEuler.
Yes, and that brings us to the first question.
First question.
Yes, for you, our audience. Which CPU architectures and scenarios does openEuler support?
Ooh, good question. So whoever knows the answer, simply type it into the chat box now.
Yes,
there are no prizes.
Quite easy.
Yeah, no prizes, but you do get our respect. That's all we offer. So the question again, what was it? Which?
Let's see. I see answers coming in.
Scenarios and architectures.
Architecture x86, yes.
Keep those answers coming. Come on, everybody.
ARM.
You're still asleep?
Right. ARM, yes. Good. Come on, guys.
Keep it coming, come on.
Yes, and we got our key answer, the RISC-V. Yes.
RISC-V? RISC-V.
Very good. Yeah.
Yeah, very good. Very clever bunch, our audience, aren't they?
openEuler now supports x86, ARM, Sunway 64, Long Arch, and RISC-V.
Wow.
Yeah, and it will be compatible with the PowerPC and others in the future.
Oh, I see. It certainly sounds like a diversified framework. That's all the architectures. There were 2 parts to your question.
Yeah.
What about the scenarios? I'm just looking at the answers.
Let me check.
Yeah, what do we have for scenarios? People are saying cloud, which is correct.
Yes, cloud.
And AI, which is also correct.
Big data.
Big data, yeah. Someone's got that.
Good. Really clever, yeah.
Are they correct?
Yes, they are correct, yeah. But there's more.
There's more.
openEuler is a unified OS that suits database, big data, cloud, edge, and AI environments, and can run on multiple devices, so such as servers, clouds, edge devices, and embedded systems.
Wow. Well, that would explain why we released the openEuler 2209 Edge and openEuler 2209 Embedded, new versions dedicated to edge and embedded systems.
That's right. So openEuler is a perfect choice for partners and developers who want to enhance computing capabilities in specific scenarios.
I agree, completely perfect. That's right. Just like openEuler 2203 LTS, the 2209 is developed on Linux kernel 5.10 and inherits the competitive features and other benefits from the community.
Yes. So now let's look at one new feature, the BPF CORE. So CORE stands for Compile Once, Run Everywhere. As suggested by the name, Once the BPF program is compiled and passes kernel verification, it can run across different kernel versions without being recompiled for each individual kernel.
This feature is available in version 2209 to address the portability issues of BPF. And that brings us to our second question. What does BPF stand for? If you know that answer, please write it now in the chat box. What does BPF stand for? Waiting for you, everybody, audience.
Let's wait and see.
No prizes today, but it should be fun. What is BPF? Okay, we do have a right answer. BPF stands for Berkeley Packet Filler, a key kernel technology or mechanism used in packet filtering and other purposes in the kernel.
Yes. Okay, now let's see how many correct answers.
Many correct answers. See how many we have. We have a very clever audience.
Good.
I know that.
Yes, we've got many. Wow. Okay, so aren't you all a clever bunch?
They are very clever.
So another feature in the latest version covers memory reliability, availability, and serviceability, collectively known as memory RAS. Memory RAS is used in key processes and the memory file system and file cache to prevent kernel resets caused by multi-bit errors.
So compared with openEuler 2203 LCS, the 2203 has a better, more complete support for memory RAS and also supports custom cache, which, based on PPF, greatly improves Redis performance.
Wow, cool.
It is.
Okay, so now let's see the ARM64 Scalable Matrix Extension, or ARM64 SME.
ARM SME is a next-gen single instruction multiple data architecture extension with more complete functions than the mainstream ARM Neon.
Yes, so openEuler now supports this feature, improving the HPC and machine learning performance for ARM64 platforms. We have another two features inherited from the Linux community. They are the Rust for Linux and the Huge Pages.
Okay. Rust for Linux adds support to the Linux kernel and helps security abstraction of Linux drivers.
That's right. And the Huge Pages can be used to map code sections in new applications, which greatly reduces the TLB misses and improves compilation.
Yes, the features we mentioned are mostly from the upstream community, to which the openEuler community is a major contributor. openEuler's kernel development team is tasked with enhancing the processor architectures, advanced configuration and power interface, or ACPI, memory management and code rebuilds, among other goals.
Yes, especially for Linux kernels 5.10 and 5.14, openEuler's code contributions ranks #1 in the world. openEuler is committed to kernel innovation and has been continuously contributing to upstream communities.
Over the past decade, openEuler has contributed a huge number of patches to the Linux kernel. And that brings us to our next question, audience. Get ready.
Yes, so how many Linux kernel patches are contributed by openEuler? Okay, just type your answers in the chat box now.
That's right. How many Linux kernel patches are contributed by openEuler? Let's get your answers in. Yeah, it's more than 100. Who wrote 100? That's not correct. More. Higher. No, answers still coming in.
Yeah.
How many patches? No, it's still got to go higher. You're getting something getting closer.
Yes, if you know the answer, just type in the chat box.
Yes, any guesses are good. except for the first one. Okay. Keep those answers coming in. We're getting closer. Get 5,000. More.
Good.
8,000. It's more than 8,000 as well. Giving you a hint here,
Just
everybody.
to try.
10,000. It's getting closer.
Yeah.
15,000. You're getting hotter. You're almost there.
Yes. So the correct answer is 17,000. Congrats if you got that right.
Congratulations. We have a winner right there. Very good.
Good.
17,000. Now, openEuler 2209 is an innovation version and naturally contains many innovative features, the first of which is the programmable kernel.
Yes, the eBPF-based programmable scheduling framework allows the kernel scheduler to dynamically extend scheduling policies to deliver high performance for different nodes.
Specifically, this framework features the tag management mechanism. The capability of tagging tasks and task groups is now open. Users and kernel subsystems can call the API to tag specific workloads so that the scheduler can detect tasks of specific workloads by tag.
Yes. In addition, this framework supports policy extension for completely fair scheduling, CFS, preemption, core selection, and task selection, and also adds new extension points and various auxiliary operations to help you easily extend policies.
Now, onto Framework as a Service, or FaaS. It is a new computing paradigm in cloud computing, and it features agile development, auto-scaling, pay-per-use, and minimized O&M, and is much more cost-effective.
Yes. We know that conventional container-based FaaS can decouple customized computing capabilities from CDN services and run fast iteration and updates. But its code start speed and memory overheads make it unsuitable to process huge numbers of instances on a single node, especially in high concurrency and heavy traffic scenarios.
Right. So FaaS is a popular trend right now, and its recent changes aim to enhance the conventional solutions that run on containers. And that brings us to the next feature, sandbox engine of the WebAssembly, or WASM. This feature provides the sandbox WASM technology, on which functions are deployed in the sandbox and isolated, avoiding issues of slow container cold start and high memory overheads in high concurrency scenarios.
Okay, but how does it work?
Well, it runs on either of the two WASM frameworks, the function management or the lightweight coroutine scheduling frameworks.
Okay, so what are these frameworks?
Well, let me tell you.
Okay.
The management framework monitors and processes high concurrency requests and manages local function images and function lifecycles. And what's more, is even compatible with OCI container images.
See. So the other one?
Well, by contrast, the scheduling framework abstracts the execution context WASM instances. It supports lightweight user mode coroutine scheduling models and supports WASM instance execution models like just-in-time and ahead-of-time.
Wow, cool.
But if that wasn't enough, we have a third feature, and that is the High Performance Computing Kit, or HCK, which is used to separate data and control planes.
Most HPC services are bulk synchronous parallel or BSP models that combine parallel communication and synchronization. But in many cases, cause system noise that is detrimental to performance.
Right. So system noise refers to non-application computing tasks executed during service running and includes system, user node, and kernel daemon processes and other issues like cache misses or page faults caused by resource conflicts.
Yes. Typically, long duration, short interval system noise has the greatest impact on the HPC performance. Though other issues like synchronization and number of running nodes also contribute to bad performance. So considered, they are all major issues for enterprise systems.
And that's why it's crucial to reduce and control system noise in HPC environments.
Yes, so that brings us to our HCK with a separate data control plane design. So this HCK feature provides functions such as CPU noise migration, CPU isolation management, task domain management, and topology filtering.
This feature isolates noisy computing tasks, alleviates resource contention, and ensures compatibility with the Linux ecosystem. Specifically, it isolates HPC tasks and those tasks that cause noise, HPC tasks that run on the lightweight kernel, while system tasks interrupt processing and kernel threads run on the Linux kernel to avoid interference on HPC tasks.
Yes, so in short, the control data plane separation aims to improve compatibility and universality to inherit the powerful Linux ecosystem current, that means the current kernel, and it supports OS development in different scenarios and operating tasks on the general framework. We know that openEuler 22.09 provides the usual high concurrency, high performance features, but what separates it from its predecessors is the virtualization feature.
Right. Yes, Stratovert is an enterprise virtualization platform designed for cloud data centers.
Okay, Stratovert, am I right?
You are right. It's a strange name, but Stratovert. Strato refers to stratosphere, the layer of the Earth's atmosphere. So here it indicates a protective layer for services on the openEuler platform.
Okay, I see. Maybe you can give us more explanation on how does Stratovert protect services on the openEuler platform?
I would love to. Well, it is a lightweight feature with minimal overheads using the memory-safe language Rust for encryption and combines multiple modules to minimize the attack surface. It can physically isolate multiple tenants to keep your data safe.
Okay, so in what sense is it lightweight with low overhead?
Well, consider when the simplified device model is used, the startup is under 50 milliseconds, and the memory overhead is less than 4 MB.
Wow, impressive stuff. What else does it provide?
Well, it ensures collaboration between software and hardware across x86 VTX and Kumpong V frameworks, and can even run fast and flexible resource scaling within milliseconds in various scenarios.
Wow. So it allows a single unified architecture to support serverless, secure containers, and standard VMs.
You are absolutely correct. Stratovert is really more than just a protection mechanism. It enhances multiple aspects of the openEuler framework.
Wow, amazing.
It is.
In addition to Stratovert virtualization, the latest version also provides HybridSKET, a feature that virtualizes the scheduling of hybrid workloads.
Yes, HybridSKET aims to address issues that affect efficient deployment and scheduling and resource utilization in data centers.
Yes, I want to take a moment and open a discussion with you and also you, our audience.
Okay.
So what methods and technologies are most useful to improve resource utilization in data centers?
That's a good question.
Yeah, of course, because there are different best practices. So this is an open discussion. And I just want to know what you think is the best practice and what are your insights into this point. So just type it into the chat box.
Okay, the question was the best methods to improve utilization in data centers?
Yes.
Okay.
Yes.
Yeah, that's a nice discussion point. I think we all need help with management in most of our environments, so it's a very good point.
Yes, that's right. So let's see whether our audience have their insights.
Yeah, well, they're very clever. I'm sure they have lots of things to discuss. They have good ideas. Oh, and there you go. We have the very first one. Someone saying QoS management,
right.
which is a very useful method.
That's right.
Very popular and very useful. Oh, and another says resource isolation. Yes.
Yes.
This is certainly a good, a typical method to improve resource utilization.
Yes, that's right.
With resource isolation, it deploys services based on priorities, or otherwise known as hybrid development, hybrid deployment.
Yes.
Which relies on resource isolation and control tech.
Yes, that's right. Okay. Yes, and for hybrid deployment, we released the feature HybridSKET. It is a full-stack solution that provides enhanced OpenStack cluster scheduling capability for hybrid deployment of virtual machine services. It is equipped with a new single node, so that's the QoS management component, the Skylark.
Skylark, very good.
So it is provided to for the kernel mode resource isolation.
That's good. Sorry, I'm still looking at our audience interaction. It's so very clever.
Yes.
But you just mentioned Skylark. Skylark is interesting as well, as it is a QoS-aware resource scheduler built for setups where both high and low priority VMs are deployed together. It improves physical machine resource utilization while ensuring the QoS of high priority VMs. Right.
Another component in HybridSKET is OpenStack Nova, a controller used for enhanced cluster scheduling. OpenStack Nova supports priority-based semantic scheduling and slashes the power consumption across the whole system by limiting the CPU bandwidth of low-priority VMs, so which further helps ensure the QoS of high-priority VMs.
Wow. Moreover, HybridSKET limits the low latency communications, or LLC, and memory bandwidth of low priority VMs, though only static allocation is supported for now. It also avoids CPU interference and supports CPU time slice preemption in microseconds.
Wow.
Simultaneous multi-threading interference isolation and anti-priority inversion.
That's right. So together, these make up some of the most innovative features and mechanisms released to date, and will help tap into the full potential of computing power.
That's correct. That was a good discussion. I like that discussion.
Yes.
Now on to our final point of today, which concerns third-party applications and desktop environments. openEuler 2209 supports OpenStack Yoga, the latest version of OpenStack released in April 2022, which itself supports the component OpenStack Helm. OpenSD, the OpenStack deployment tool, is used for basic deployment of OpenStack Yoga on openEuler 2209.
Yes, and what's also new is hybrid deployment of VMs using OpenStack Yoga. It provides high priority and low priority VM technology, so whereby VMs with different CPU I/O and memory resource demands can be deployed and migrated to the same compute node to fully utilize node resources.
Right. For file, backup, and restoration, openEuler 2209 provides functions such as system backup, file backup, custom restoration, and even one-click backup and restoration to help you slash traditionally expensive O&M costs.
That's right.
That's right.
Yes. The openEuler 22.09 also offers great compatibility with desktop environments. First is the DDE. The DDE is upgraded to support the control center, file management, and system monitoring, and log collection, and many others.
Also supported is Cinnamon desktop environment for the file management and for the control center. Most importantly though is the fact openEuler now supports Kirin 2.3 for the control center plugins and volume, while network settings and Qt theme plugins are now available.
Yes.
It's really quite comprehensive, very impressive stuff.
Right.
And that brings us to the end of this video. Thank you for joining us. We hope you enjoyed it. The key features of openEuler 22.09 and the latest changes to the OS are certainly an interesting topic.
Yes. And to find the latest version of openEuler, please visit our official website. Or you can learn more about the community and engage with like-minded individuals. You can visit our repo on GitHub.
In the next episode of openEuler Tech Day, we'll go into some more details about openEuler key features and practices.
Yes, but before we go, the Chinese New Year is coming up soon.
It is.
Yes. So what are your plans?
Oh, Chinese New Year, nothing yet. We'll probably take a day trip somewhere.
Cool.
We live in Sichuan, so that's,
Wow.
beautiful mountain ranges that are easy to get you to in just a few hours. But I will take this opportunity to send my best wishes to all of our openEuler friends around the world. Stay happy and stay healthy, everyone.
I couldn't have said it better myself. Happy Chinese New Year. Stay tuned, and we hope to see you in the openEuler community soon.
Yes. See you next time.
Bye.
Bye-bye. Happy Chinese New Year of the rabbit,
Happy Chinese New Year.
Is it the rabbit?
Yes, that's right.
Oh, okay.
The year of the rabbit.
Rabbit, rabbit. Rabbit, 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 rabbit.